Okay, hello and welcome back to the course. This is the eighth session of our basic Python course, and today's topic is the standard library. This continues our last session on modules, and therefore, before we start, I'm going to make a brief recap and some terminological remarks. So, in the last one or two sessions, we saw the difference between modules and programs, where roughly speaking, modules are collections of tools and programs are scripts accessing these collections of tools. And we also saw the difference between writing a module and reusing a module. So you can write a module and run it as a program on its own by including a test section at the end of the module, or you can just reuse this module by importing it from another script or even supplying it to colleagues who then import it in their scripts. Okay, so when we speak of the Python core, what we mean is the sum of all of the following. There are a few built-in functions that we were also already using, such as the print function or the input function, some necessary math operators in order to perform the required operations on integers and strings, for example. The most useful data types, such as int, float, string, list, dictionary, and some control statements, which allow us to make our program a bit more interactive and introduce branching structures, such as if clauses and for loops. Okay, so this is the Python core. And the standard library, what will be the topic of today, is a collection of modules for common programming tasks. So there are several tasks that occur often in programming, such as advanced mathematical operations or dealing with files and directories. And the modules which allow us to accomplish these tasks are not part of the Python core, but they are part of the standard library that is usually supplied with the Python core. So when we say Python, what we mean is the Python core plus the standard library, which also means that when we're using tools from the standard library today, we don't need to install or download any modules before doing that. This will be possible automatically. Okay, once again, we want to set ourselves some objectives that we want to solve or tasks that we want to accomplish. And the first objective that we want to have a look at is the following. So here's the first task. We want to create a new model for working with circuits, and the module should contain two functions. One function should calculate the circumference of a circle as a function of the radius, and the other function should calculate the area of a circle given its radius. So in order to do this, we obviously need the formulas for circumference and area of a circle. You can now pause the video and try to remember these formulas on your own. If you don't, here they are. So the circumference of the circle is pi times the diameter of the circle, which is equivalent to 2 times pi times the radius. And the area of a circle is pi r squared. So as you can see, both of these formulas include the mathematical constant pi. So in order to calculate these things in our program, we somewhere need to define pi. So what we could do is just have one line in our program saying pi equal to 3.14159 and so on and so forth. and then later use this variable pi in our mathematical operations. Now, this is not a perfect solution because on the one hand, pi maybe has a larger decimal extension than what we have um, written down here. So this may not be the exact value. And another advantage is that in every program in which we are using pi, we need to define this constant at the top. And there's probably a better solution in Python. So in order to find out a good solution for how to do something in Python, you can often just Google things. So I now switch to my web browser and Google Python Pi. Okay, so let's use this one here. And this is a brief article, how to use Pi in Python. And if we skim through this, we see that we need to import the module math, and then Pi will be available to us as math.pi. So let's just try this out. I'm importing the math module. As you can see, there's no file named math here in the current working directory. And I still can import this module without an error, which is because it's part of the standard library and it is automatically there. So remember that in order to find out what's in a module, we can just dir this module. So use the command dir with math as input. And we'll then see all the things that are contained in the math module, and a lot of them appear familiar to us, such as the sine and cosine function. There's e, which is another mathematical constant, and there's pi. So let's type math pi. Great. So this is pi, and we can use it to calculate it. If you remember our last session on modules, you might recall that in the modules that we wrote and in the modules that you wrote for homework, we didn't have like variables or constants contained in this module or these modules. We always had functions. But it's perfectly possible to, in a module, to not just define functions inside the module, but also define variables. So if we ask for the type of math.pi, it's a float variable. However, there are other things in the math module which are actually functions. So we can, for example, take a look at sqrt, which stands for square root, so calculating the square root of something. And if we ask for what this is a built-in function. Okay, so with pi available from the math module, we in principle have everything that we need to achieve the required task. So we can define a radius, let's say 10, and calculate the circumference of a circle with this radius. And get some result. So a circle with radius 10 has a circumference of 62.8 something. Great, we can also do the same thing for the radius. I'm sorry, for the area. The area is pi times radius squared. So double times means raise or to the power of. And if we print it, we learn that the area of a circle with radius 10 is 314 point something. Okay, so we can now use these calculations in order to write our little module. And I'm going to make this a little exercise. So if you want, you can now pause the video and take some time, maybe 5 to 10 minutes, to turn these commands into two functions inside a module. So our module should be designed such that it behaves in the following way. So when you've written your module, it should be possible to do this. Okay, great. So I'm gonna show the solution now. I have a module named circle here in the current working directory. I'm not gonna open it because I first want to try it. Import circle. That succeeds. And I access the function circumference inside the circle module and calculate circumference of a circle with radius 10, which gives us this, the number which we already know and which is correct. And similarly, I can calculate the area, which is 314. Okay, I'm opening the module now to show you how it looks inside. Actually, you can solve this task with just 4 to 5 lines of code. Most of the code lines in the scripts are comments. So all we need to do is to import math, and then we can define two functions, area and circumference. And in both of these functions, we just need one command, namely to return pi times r squared in case of the area, and 2 times pi times r in case of the circumference. You could, of course, also divide this into two code lines. First, calculate the area, store it in some variable, capital A, for example, and then return this variable. This is a more succinct solution if you want. And there's also a test section in this module, which, if it is run as a program on its own, prints the area of a circle with radius 51 and the circumference of such a circle. So if we now run this from the editor, we see that it's correctly working and it's actually printing those quantities. Great. Okay, with that, we want to come to our second objective, which is the following. So once again, we want to accomplish the following task. We are preparing to organize our tax returns for the last 5 years. And so in German, this means Steuererklärung. And we would like to generate a folder structure in which to store them. We need one folder for each of the last 5 years. And inside each of these folders, we would like to have a separate folder for each month. Okay, obviously, in order to do this, we need to know how to make new directories in Python. So let's just go back to Google and ask Python, create new directory. We also search for make new folder or whatever. Let's take this one here. And it tells us that for creating a directory in Python, we need the module OS, where OS stands for operating system. So the module operating system allows the user or the programmer to interact with the computer's operating system. And most importantly, this allows us to interact with the file system of the computer. And then there are two functions for making new directories: mkdir, mkdir, and makedir. And we will see what the difference between these two is in a few minutes. Okay, so in order to start, let's go back to Spider and clear this here. And first, let's import the module. Once again, it works without a file named OS being available on the current working directory, which is, as I said, possible because these modules belong to a standard library and are automatically available to us. So let's just try the first command. We saw that we need the command mkdir from the module OS, and let's simply name our directory my new directory. Okay, so how do we find out whether this new directory has been created? Well, because we here have the Files tab on the top right, we immediately see that there is a new directory called my new directory. But we can also use the OS module itself to find out where we actually are. So get CWD, get current working directory, tells you the current working directory, and you can then head over to the Explorer into this directory to see whether the directory has been created. And then there's another function called listdir in the module OS, which lists all the files from a specific directory. And if you provide no input argument to this function, it gives you the contents of the current working directory. So let's just do this. And we see that there are a couple of files, all Python programs, and also one directory called my new directory. Okay. As you can see, the output of this function, listdir, is a list. So we can use logical checks to ask whether our making a new directory succeeded. So we can just ask whether my new directory is in the contents of the current working directory. This is true because this string is contained in this list. Great. You can also change to a directory using the function chdir, where ch stands for change to directory. And let's just change to the directory we just created. And as you can see here, on the top, we now switched to this other working directory, which we can also verify by getting the current working directory again. Okay, let's go back and then have a look at another function, namely rimdir or rmdir, which stands for remove directory. So we're now, before we work on our objective again, trying to just remove the directory in order to get to know all those functions in the OS module. Okay, and if we were not able to immediately see the file contents in such a tab folder here, we could once again check that programmatically using code by asking whether the directory name is in the contents of the current working directory, which now is false because we've just deleted this directory. Okay, obviously, deleting a directory which doesn't exist should give an error, which is true because you cannot remove a directory which isn't there. However, we have learned in earlier lessons that such error messages can be intercepted if they occur, such that our program doesn't abort if they occur. So I've here prepared a little demo script for removing the directory. So I'm running the same command again, trying to remove the directory, non-existent directory. But this time I'm going to put this into a try and accept clause, which means that I'm going to try and run this command. And if I get a file not found error, the program doesn't abort, but I get a warning, which tells me that the directory wasn't removed because it doesn't exist. So if I run this program, I don't get the same output as before, but I get proper warning telling me that the directory wasn't removed because the directory doesn't exist. So removing non-existent directory gives an error that can be accepted using the try and accept structure. Okay, so I'm going to now open this script, years version 1. And this script is yeah, a first version of the program that we need to solve the task. So what's being done here is that we are importing the OS module because we need it for creating directories. And then we define a year, let's say that the first year is 2015. And we define a list of month abbreviations. So January, February, March, and so on. And then we create a directory for this first year. As I said, this is just a test. And then we change to this directory. And as soon as we are inside this directory, we're going to create one directory for every month in the list that we have defined above in line 4. Okay, let's run the script and see what happens. Okay, so two things happened. First, we can see that if we look into the Explorer, there's a new directory named 2015, including 12 folders for all the months. Fine. And second, our current working directory has changed to this folder 2015, which is also plausible because we had a command doing this in our script. So we could now use this solution in order to solve the required task. But before that, let's do a few checks. So first, we want to know how to get back into our original directory. So we could use change directory and simply, yeah, copy the directory, the parent directory to which we want to change back as an input argument. But we won't do that here. We will use the abbreviation ... So this command changes to the parent directory of the current directory. So in other words, it just says move one level up in the directory hierarchy. So if we do this, we are back into in the original directory, and we can verify this by asking for the current working directory. We can also check whether the year folder, so folder named 2015, is in this working directory, which is true because we have just created it using our script. And we can then use the function listdir to list the contents of this folder. And we see that it has 12 subfolders corresponding to the month. Okay, so this all worked fine, but we're still not going to use this solution for solving our task. Why are we not using this solution? Well, the answer to this is that you should not change the directory inside a script. Yeah? And I've here prepared a little demo to tell you why. So this script again imports the OS module, creates a new directory, changes to this directory, and then asks me how many new folders I would like to create. And then for each, depending on the number that I have inserted, it's going to create folders named 1, 2, 3, 4, 5, up to the number that I was inserting. And then it changes back to the parent directory. So if we are here changing from the current working directory to my new directory, we know that this command should bring us one level up again to the directory, into the directory from which we are starting the script. Okay, so if I run this program, how many new folders would you like to create? Let's say 5. And I can then move to the Explorer to see that there's a new directory called my new directory with subfolders 1, 2, 3, 4, 5. Okay, great. I'm gonna delete this and run the program once again. And this time I'm not entering 5 as a number, but I'm entering 5 as a string. Okay, obviously I get an error because we have this line here in our code, line 7, which instructs Python to convert the user input to integer. Now, the word 5 cannot be converted to integer because Python has no internal algorithm converting like words into numbers. So this is not a valid numerical input. But now have a look at where we are after the program has aborted. We are now inside the new directory that we have created. Although the intended way of operating of the program is to change back to the parent directory at the end of the script. However, the end of the script was never reached because there was an error message at this position in the script. So if we now started the program from this directory, it would not be in the directory where we originally started it from, and it would create a new subdirectory, my new directory, and so on and so forth. So for the little programs that we are writing in the context of this course, this is not a big deal. We can just go back to the parent directory, delete everything, and start over. However, as soon as you're writing larger programs, which probably have multiple components, this can bring you into serious trouble because your program will move back and forth between the directories and you will never know precisely where you are in case that there are error message and your program aborted somewhere halfway. So this is the reason one should not change directories inside a script. If we shouldn't change directories inside a script, then the question is, how do we solve our task? So in order to understand this, let's first deal a bit with file path names. So I'm gonna clear this again, and I ask you to enter the following into your Spider console: OS path zap. This is an abbreviation for give me the separator for path names on this operating system. So if I hit this on my machine, I get double backslash, which, as you know, because backslash is an escape character, corresponds to a single backslash. So if you are using a Windows computer, you're probably gonna get this output. If you are working on Linux or Mac, you will probably get a normal slash as an output because this is how folders in file paths are separated on these operating systems. And then there is in the path submodule of the operating system module, the function join, which allows you using this default separator to combine several folder names into a path name. So if I hit enter, I here get the following folder double backslash subfolder backslash subfolder. Once again, on Linux and Mac, you will probably get folder normal slash subfolder normal slash subfolder. So when it comes to path names, there are two types of path names. First, there are absolute path names. The absolute path names are what we usually see when we are in some file explorer. And we can also find out in Python what the absolute path name of a specific file or folder is. So there's a function called absolute path in the path module. And if I use my new directory as an input to this function, I get the absolute path of this subdirectory. So the full path specifying the location of this folder on my computer, which is equivalent to what I see here, for example. Now, for a lot of reasons, it's mostly better to work with relative path names, because if you work with absolute path names, the program which you're writing is contingent on the specific computer on which it is run, which is very unfortunate. And for this reason, we are working with relative path names, which are always path names relative to the current working directory. So, for example, like this one here in 39. For example, if we join the two folder names 2015 and January, we get the following relative path name. And relative to the current working directory, this would refer to this directory. Okay. I'm going to delete this folder 2015, which we have created using the first version of our program now, in order to make a little test. And the test will be as follows. I'm writing the output of this operation into a variable called directory name. Let's safety check whether dir name actually contains 2015 backslash January. And I will then once again use the function mkdir, which we've seen in the very beginning of this part of the lecture, in order to create this directory. And we get an error. It says file not found error. The system cannot find the path specified. And the reason for this is that mkdir always attempts to create the lowermost directory. So in this case, mkdir understands this as create the folder January inside the folder 2015 relative to the current working directory. But there is no folder 2015 in the current working directory, and therefore we cannot create the directory January in this folder. And the solution for this is the function that we have seen back in the beginning, makeDirs. So if we instead of mkdir call makeDirs with the same input, directory name, which once again is 2015 backslash January, makeDirs succeeds and creates all the directories that are necessary in order to reach the specified file path. So you can see that here we have the folder 2015 with a subfolder January. So once again, to repeat, mkdir only creates a single directory, and it always attempts to create the lowermost directory in the hierarchy, whereas makeDirs creates or attempts to create all the directories in order to reach the specified folder at the lowermost directory. Great. Okay, so with that, we have all the prerequisites that we need to fulfill the objective that we set ourselves, creating the folder structure, without having to change directories, because we can create all those directories from the current working directory. So you can now once again pause the video for like 5 to 10 minutes and try to write this little program. I'm going to put up the task here once again. Okay, I'm going to show the solution now. So I'm opening the program years version 2 and briefly explain what it's doing. So first we are again importing the module OS because we need functions from this module. And here this program also defines a main directory name such that all the yearly folders are placed in some folder, and we don't have them all in the current working directory. So what you see here in line 3 is an extra relative to the task that you were tasked with in the objective. Then we define years as a range of numbers from 2015 up to, but not including 2020. If you can work that out, that's 5 years, 15, 16, 17, 18, 19. And then we once again create the list of month abbreviations, which we already worked with before. And we're going to have 2 loops, an outer and an inner loop. The outer loop runs over years, and the inner loop runs over months. And then within each iteration of the inner loop, we are creating a new directory name, which consists of the main directory name, which in this case will be invoices, the year converted to string because it's a range object. Therefore, each individual object from it will be a number, and the months string from the list of months. And these are joined together, accounting for the default path separator on your operating system. And then the function makeDirs is being used to create these subdirectories. In the first step, it will have to create invoices and the year 2015 and January. In the second step, obviously, it will only need to create February because invoice and 2015 have already been created, and so on. And then we also get a little message confirming that the directory has been created, which is also an extra relative to the specified objective. Okay, let's run the script, and we get a nice list of display output, and we can also verify that everything has succeeded by having a look into the invoices folder. So we have 5-year folders, and in each of them we have 12 months folders. Okay, great. So this concludes the second objective for today. And at the end, let me just say a few words about so-called third-party packages. So given that what we worked with today is referred to as the standard library, there's probably also something like the non-standard library. And the non-standard library is usually referred to as, or are usually referred to as third-party packages. So third-party in this case means that it's neither you that has created them nor Python that has supplied you with them. And packages means that these are usually collections of modules which add new functions to your Python installation. There's also a Python package index. So PY, PyPy, also called PyPy, and this is something like a repository for all third-party packages which have been made available publicly for the Python programming language. And obviously, there are a lot of packages on PyPy, and not all of them should be used. So there's definitely a lot of trash on the Python package index. And if you want to find out whether you should work with a package you find on the index or not, you should ask yourself 2 questions. So that a package is available on the Python package index is, first of all, no guarantee that it works correct or is up to date. So you should ask yourself 2 questions. First, do many other people use this package? Then this is a sign that it's being actively used. And if it's mentioned or recommended in online tutorials, that's an even better sign. And second, is the package still being maintained? Is there some text telling you who the developer of this package is and how to reach them in case you run into problems? And if you can answer yes to both of these questions, then it's usually a good idea to use this package. The great advantage of Anaconda, so our Python distribution, is that there are a lot of popular third-party packages are already installed. So popular packages, for example, include NumPy for numerical operations, mathematical operations, dealing with vectors and matrices, SciPy for scientific computing, and Pandas. And as you can see, I don't have to install these packages before importing them because they are supplied. They do not belong to Python and they do not belong to the standard library, but they are very popular and very often used, which is why they are already included in the Anaconda Python distribution. Okay, so this concludes our session about the standard library. Thank you very much for listening and hope you enjoy the other videos as well. Bye bye.